Hey, Charles.
Hey, Michael.
We've got a quick little mini topic to talk about, which I'm calling messing with rewards.
Okay.
And so just to give you a sense of what that's about, I mention Ing Harada and Russell, who are, they wrote a paper that covers the ground that I'm going to talk about. And then to make it more vivid, I drew a picture of me messing with the reward function. And when I asked Google for a picture for this is what it came up with. So that's Deborah Messing winning an award.
And that seems absolutely appropriate. She's got the same look on her face that you had on yours.
I know. That's what I thought. That was really interesting. I was surprised that Google did such a good job. I think image search is getting better because of machine learning.
Probably reinforcement learning. I hope you gave it a little reward.
Oh, I forgot to do that. All right, I owe it one. So I wanted to start off with a question to you, which is if we're going to be tinkering with the reward function, why might we want to do that? Why might it make sense to take a reward function for an MDP and then turn it into some other reward function?
Because it's easier.
It's easier to change it than to not change it?
No, just we might get a reward function that's easier to solve. And since the whole point is to solve the MDP, we should just make that really easy.
Yeah, so if we can find a way of changing the reward function in a way that makes it easier for the learner to work with, then and without actually changing what it's going to learn as a result, that's a win.
Oh, I wasn't going that far. I just figured we'd set the reward to 0 everywhere, and then everything would be easy.
Ah, that would make it easy, but I think it should be easier to solve and similar to what it would have learned otherwise.
Okay, I guess that's fair. That seems like less cheating. But it does invite a question. Maybe we don't want to get into a philosophical discussion here, but where did the reward function come from in the first place? I mean, I think the way you pose this question sort of suggests that there's a true original reward function.
That's a good question. So, so why might we want to change the reward function? Because we don't have one yet.
Right.
I think that's a really good point, and you're right. I'm not going to get into that, but but this is a topic that you know that I have a lot of interest in because you and I have been meeting on this subject for a year or so, trying to figure out if we think about reward functions as being ways of encouraging reinforcement learners to exhibit certain kinds of behavior, then they're kind of like a programming language. They're kind of like a way of specifying behavior that then is going to get compiled by the learning algorithm into actual behavior. And so there isn't actually a lot of work on on how to do that. If we have some idea of what behavior we want, what reward function would be appropriate to make that happen. So you're right. So in some sense, I'm finessing that question and instead saying, yeah, somehow we have a reward function and we want to tinker with it, maybe to make it easier to solve, maybe to make it easier to represent, or easier to reason about, or any of a number of possible reasons, but without actually undermining what it is that the behavior is supposed to be that's being specified by that reward function. Because as you said, it's really easy to just turn the reward function into all zeros, and then all policies maximize that reward function. In which case, learning is done.
Yeah, and then we solved a problem, just not necessarily the problem we're trying to solve.
Yeah, that's right. And that's always an issue in AI, I think, is we have to worry about turning the problem into an easier problem that isn't really interesting anymore.
Right. So, by the way, something you said made me think about something. Well, two completely unrelated things. So, you call the reward function sort of like a programming language. I like that. One nice thing about that is it let us think about this easier to solve thing while still being similar, saying, well, if you have a program that allows you to sort, well, there are many different programs that could allow you to sort, and some are actually more efficient than others. And they're more efficient both in terms of the time it takes them to run, more efficient in the space that they use, and they're more efficient in the sense that they're easier for a human being to write or to think about, even though they're ultimately going to exhibit the same behavior, which is sorting a list. So I like that. And then it makes the question of why would we want to change a reward function make a little more sense. And that ties into the second thing I wanted to say, which is you say easier to solve, but you haven't said what that meant. I could think at least two things it could mean. Easier as in faster, or easier as in might be solvable at all. Like there may be a reward function that becomes extremely difficult to solve.
So I summarize what you were saying to me as, first of all, if we think about reward functions as a certain way, we at least gives us an idea of what semantics is. Like, what is it that we want a reward function to make the agent do? And at the moment, we're going to finesse that and just say, well, whatever it is that the old reward function made it do. But then we can also think about changing it in a way that doesn't change the meaning, but does make it more efficient, either in terms of the amount of data it needs to learn or the computation that it needs to learn. I mean, I guess speed really has those two different pieces, right? One could be how much experience does the agent need, And then how much computation does it take to actually carry out the learning process? And that could be easier or harder. If you don't have to plan ahead super long, then it might actually be faster in terms of computation. And other kinds of efficiency include space, sort of the complexity of writing down the reward function, and maybe whether it makes a problem solvable at all. Maybe the efficiency is the difference between infinity and not infinity.
Yeah, which is a pretty big difference most times. I mean, in the limit.
So good. All right. So let's think about some ways that we can actually change the reward function without changing what it is optimizing.